So okay, so here I send request, and this guy sent back confirm message. Okay, but because I put observe here, zero flag, zero here, and then mean, you know, if you change value, please let me know, something like that. So you can see that if line change here, they will send an event or maybe send a request back to the client or the observer, and then this guy just send acknowledge back to back here. So here token play an important role. Okay, so that's why they need two kinds of ID. One ID is request response called message ID, and as you know that in the observe spec, they also need a token to denote that, you know, you respond to this guy, because, you know, they have some kinds of requests long time ago. So you keep doing this instead of just once, something like that. Because observe flag is one. But observe flag actually is not quite finished yet. For example, it depends on your implementation. For example, one thing you can do is, you know, they check every second if the temperature or the value you want to measure difference. They send it back automatically, or maybe you can set 1 minute. So when 1 minute reach, and then you measure the previous one and the and the current value. If they are different, you send the request message, something like that. The other thing is you might say they have two kind of threshold. One is too hot and the other is too cold. And between these two values, they are okay. But right now there is no way to specify something like this, because the CoAP haven't complete this observed spec at the moment. So okay, enough talk. That's okay. You have
a question. On the CoAP transmission, like you got an acknowledge, and I think they can you put back the picture 121, please?
121. Okay.
Yeah. Oh, yeah, maybe before. Thank you. The one before. Yeah, this one. You acknowledge only the number with the number of the tram of the package you send. But how do you know that the content of the packet is okay? It's not because like you did in some protocol communication, you've got like some control, like a CRC to control the integrity of the package. But on here, like
CRC we're doing in the first layer. It doesn't matter, you know. If CRC is error, then the whole thing is the wrong message.
Yeah, but do you have a CRC?
No, there's no need. It's just, you know, a UDP, right?
Yeah, but like so you acknowledge like I received the packet, but how do you know that the packet content is right, is not corrupted?
You have OSI, you have 7 layers, right? And OSI standard, you have 7 layers, and UDP is in the 4th layer.
Yeah.
And the CRC actually will be lower than the 4th layer. For example, physically, the physical layer, they would do the CRC check. And if you want to, I guess the layer 2 might have some kinds of, you know, error detecting mechanism. So you don't need to worry about. This is a high level.
Okay.
So okay, let's try to write our own CoAP application. There are 4 steps to write a complete CoAP server. First is you add the resources, add the actuator resources. Sorry. So you write some actuator functions. What do you mean actuator function? When you try to control something from the client, something like you send a message from your smartphone, right? So you send a request over the internet and then go to your broker. Sorry, not broker, your CoAP server. So you must have some way to say, okay, I received some message from someone. This is kind of request, and he asked me to do something. So you have to write, we call it actuator functions. And how about sensor? If you want to read some kinds of sensor, then the sensor have to kinds of keep update its value. So if you want to read, then they just send the current value back to you. So that's why you have a loop. It's similar to your embedded system, right? Anyhow, you every second you update, you read the temperature and you read the lightness, and you keep updating to your server. So when the server send a request to read your maybe lightness, then you just send back the current value to you. So here the embedded system for actuator is a little bit different, but for the sensor are exactly the same when you write embedded system. And then you can add some device info. For example, these devices actually cannot be turned off if you want to save power. So for example, refrigerator or some devices for security. But maybe in some other devices like your TV or maybe your stereo, when you when you go to bed, you want to turn them off automatically. So you can add some kinds of device features to it. But we are not going to talk about this. And then you have to register your sensor and actuator resources. What do you mean sensor resource? It's just variable, right? Because you keep updating this value, right? So as long as the server understand or make the server have the current value, then any request sent to the CoAP server, they can respond automatically. And what do we mean actuate the function? That means when the CoAP server receive a request, they have to understand which function to call, and it's kind of register a CoAP function. So here we write an actuator function, and then we register as a CoAP function. So your smartphone have to understand if you press this button, then you call some kinds of actuator function there. That means you register a function, and far away from you, you have many client or maybe your smartphone, and they can use this function. They call this function and call that function. It's similar to kinds of remote procedural call, but you have to register what kinds of functionality you have. And the last one is you need to let other know, I am a coffee machine. I have this kinds of capability. You can use me. Okay. So let's try to. Maybe we try the CoAP. This is the the whole things, but probably for the temperature, there is no actuator at all. So may I have my device back? So first you have to do some auto connection. That means these devices these end devices were auto connected to the gateway. Okay. So maybe you have another end devices. They can also automatic connect to the gateway. So the auto connection is doing something like this. The second is similar to your embedded system, right? You have a timer, which is in pin 7, right? So you use a timer, and that means every minute you want to read the information, and this part is you can put it out or you don't. It doesn't matter. But I mean, for the debugging purpose, you print something out and you can see if anything is okay. And then this is the first step. Just add your sensor resources, and it's exactly the same as you doing the embedded system designs. Here is the CoAP server. First, we start the CoAP server, and the UDP port is 5683. And here we also describe what kinds of devices I have. Here you can say I am a coffee machine, or maybe I am some other, like a fan, or maybe I a smart plug. You describe here, okay. And then you add resources. Here, things you have a temperature resources and humidity resources. So here we just, register the server that these two values can be read from outside world, but they have to tell others what this value is. So here we can say that this is sensor. So here is mean a sensor category, and you might have two temperature, right? So if you have two temperature, this is instance 1 and instance 0. You keep adding it. For example, in our smart plug, we have 4 switches. So you will indicate instance 0, 1, 2, 3, something like that. And then the resources mean what kind of resources. It is the temperature. The temperature is marked as 1, and the humidity is marked as 2, and lightness is marked as 3, and there are some other value we can check with our program. So here is our program. First, we new an object. Okay, so just like what you do in the sensor, right? So remember last week we say that first, if for the sensor you set the pin maybe 7 in our case. So the 7 actually, yes, it connect. So that you have 7 pin as input, and also you want to read the temperature, right? So read the temperature. So you put 7 here. This is just for safety check, because you won't know, previous one was maybe set as output. So for your safety, okay. And then you need a timer, right? You need a timer. So you use the zeros timer, the first timer, and it's in every second. And you maybe, if you want to read faster, you can change the value as well. And maybe you would want to do some debugging, right? This just similar to our embedded system. So you will say temperature equal, and then you drag and drop the temperature. And then you will say humidity equal, and drag and drop the humidity, and then put it here. So this is exactly the same as your embedded system. So okay, so could you stop, and maybe we can say how are we going to make it as a CoAP server. So go back to the CoAP view. We have auto connection for you, so you can do your devices when you power on, they can automatically connect to the gateway. And also here, this is the actuator function, which in this lab we won't use it at all. We have only sensor, and then we start a CoAP server. And here you can choose what devices you have. So here it could be sensor and actuator. The default is it could be both sensor and actuator. Maybe in this case we can say it's 1-to-1. It is only sensor only, right? So and then you add some kinds of sensor object to it. So this is sensor object, because I don't think I need to describe this again. And this is which object it is. And this is the resources. One is temperature. So I just register the temperature variable to the server. And again, we can do it again. So we go to the second resources is humidity, and we drag and drop the humidity here. And we put it back. and then click this one, and the code will be automatic generated for you. So that you click here again and export the Lua file, and then that will be in here. Okay. So first I connect to the devices. So what's that? So you put some in. Okay, so I have to rename it. Oh, you erased my code. Don't do this.
I will flashed all the code.
Why?
I can see that
we had some problems to
But if you erase them, then there is no CoAP, there is no MQTT.
I still got.
But you can keep adding. They will not interfere with you. Why you?
No, it was like to rate like all they wanted like a lot of different file, and it was like just quicker for us. But I save everything I got on my computer.
So after we export to this one, and we just send it to the ESP8266. So right now they will do some auto connection. So they try to connect to the gateway. So this is your IP address 141 here. So if you have phone with our app, so you can see that oh, so many devices. 3. I'm not sure which one. So you can see that right now actually I connect to maybe the other one, so maybe not this one, maybe BOC. I'm not sure this guy connect to which. No one. Oh, the second one. I guess we have already have server here, so you have to choose the. Okay, this one. So you can see that the temperature and the humidity already show on your screen. If I put the heart A, you can see go up, and the humidity also go up at the same time. So if your device, have your own board connect to this guy, then the dashboard automatically show it to you. How are we going to do it? Because you tell me that you are temperature, you are sensors, and you register your temperature, and you register the humidity. So I will show it here, and maybe you can also register to the light sensor. So you may go back and do your light sensor, something like that. And maybe I would try to do the activation. Try to do the you add a light sensor by yourself and see if you have any question or not. So based on this code, maybe we should start. Okay, still okay. So we also have LED here, right? So when you try to control the LED on and off, it's not a sensor. You have to say, I want to turn on the light or turn off the light. So in here, you have to register and actuate the function. Okay, so that's a little bit different. So you can see that here we have actually this is have LED state and the LED pin. So the pin is pin 4. Okay. and we set the pin 4 as the output pin. Is for safety, okay, and we make sure that it is in the low state, something like that, or maybe in the active high state. It depends on the active high or active low. And then you write an actuator function. Right now we have to think about, actually you maybe have a smartphone here, and smartphone send a message to the server. And the server actually understand that you need a service from this code. Okay, so you have to understand that which function you want to use, and also what kinds of parameter I should take, so that they can run the code, and then finally they will return, the status of the resources back to you. Okay, so this is why you need an LED status here, because when you turn on the light, you have to tell your smartphone that the light is on, right? So you have to send back the status to the smartphone, something like that. Okay, so here you just print out the payload. Maybe I will receive 1 to turn it on, and receive 0 to turn it off. You have to remember that everything in the internet are strings instead of integer value. So here the payload could be 0, could be 1, but it's 1 string and 0 string. Okay, so that the payload, if equal to the 0 string, then you turn the light off by setting this to the status to 0. And then you active low, so you set this pin 4 as high. Or if you receive a 1 and you need to turn on the light, so that you keep the state LED to 1, and then you rewrite the pin to low to turn on the light, and then you have to register this function, this CoAP function. So you add resources by saying that I am an actuator, but right now it is both actuator and sensor. So I will switch this one to 120, which means it could be sensor and actuator at the same time. So how am I going to doing it? So here we add actuator function. First we click the function and we will say set LED. And this is the payload. And remember, we need to understand the status of the LED, right? So we have a variable. So we will set the LED value to maybe in the beginning is 0. Okay, it's off, something like that. And then you go back to the actuator. For safety, you set the pin 4. Don't use pin 0 because the pin 0 is used by the auto connection. If your device is flashing, mean they try to connect to the gateway. Okay, so use pin 4 instead of pin 0. And I guess, okay, maybe one thing I can do is the right pin to 1 to make sure the state is, remember with pin 4, and too high mean that this will be off, right? So this kinds of initial states. So we can drag and drop the LED here because things we keep updating the internal state of the LED. And then we drag and drop some if else here. So if I receive, if the payload actually are 0, remember it's the string 0 instead of 0. So in the NoMCU we have a string, So we say it's equal to 0 string. They mean you want to turn something off, right? So actually here actually turn something off. So we can say maybe just copy this here. Turn something to 0. and then set the pin 4 as high. The other is you can duplicate the code here, and then you say if I receive a 1 here and I turn on the light and it's active low, so I set the pin 4 as low. Okay, and then I need to register my resources, so go to the CoAP and you add actuator here. Remember here, okay, right now I'm both sensor and actuator, so I should change to 120 to denote I'm both sensor and actuator. And then I drag and drop the code to here. Okay, so this is the actuator, this is the sensor, and I need to register the function, register copy functions. And I also need to say which function it is, what kinds of function. It is LED, so I would choose 201, something like that. So you can click again, and then send to the IDE. Right now, usually I will reset it, make sure the old program is gone, and then I send to the ESP. So you can see that the light here is present, mean they are trying to connect to the gateway. So F to connect to the gateway is 144, and the light will not present anymore. So you do the refreshing. So where is it? There are 3 gateways. I'm not sure which one is connected to. Let's check one by one. No. Why? The first one. Do I do something wrong? Okay, here, right? So I can turn on the light. It's on. I can turn off the light. Just you did. But I may take only 5 minutes to do the whole things. I'm not sure how long you working on. Turn on the light and turn off the light. And for the CoAP is quite easy. Okay, so what's that? 暖气机. They are trying to do something else. Alright, okay, this is the CoAP. So, any question? Maybe for the rest of you can try to do it. So, you might add a light sensor, as I mentioned, to it, and maybe you can